Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today we are mastering LeetCode 383, the Ransom Note Challenge. This is a fundamental string manipulation problem that tests your ability to efficiently count and compare frequencies. Let us look at the problem statement. We are given two strings, ransom note and magazine. Our goal is to determine if ransom note can be constructed using the letters from magazine. But remember, each letter in magazine can only be used once. If we have all the required characters, return true, otherwise return false. For our strategy, we will use a frequency map. Think of it like a warehouse inventory system. First, we scan the magazine and record every letter we have in our inventory. Then, we go through our ransom note, and for every letter we need, we check our warehouse. If we have the letter, we take one out. If we run out of a letter, or never had it in the first place, our note cannot be completed. This approach is incredibly efficient, requiring only a single pass through both strings. Let us dive into the dry run. Look at the screen. We have our ransom note. A, B, and our magazine. A, B, C. At the top, we have our magazine scan, and on the right, our frequency map. First, we scan the magazine. We see A, so we add it to our map. Another A, now we have two. We see B, add it. Finally, C. Our inventory is ready. Now, we process the ransom note. First character is A. We check the map, we have two A's. We use 1, so the count drops to 1. Next, another A. We still have 1 left. We take it, and the count becomes 0. Finally, we see B. Our map has 1 B. We take it, count becomes 0. We have successfully processed all characters in the ransom note without running out of inventory, so our final result is true. Now, let us look at the Python code. We start by using the counter class from the collections module to create our frequency map of the magazine. This one-liner efficiently builds our inventory. Next, we iterate through each character in the ransom note. Inside the loop, we check if the character is in our map and if its count is greater than 0. If it is, we decrement the count in the map. This represents using a letter from our magazine inventory. But, if we find a character that is missing or has a count of 0, it means we cannot finish the note, so we return false immediately. If we finish the loop without any issues, we have found all our letters, so we return true. Looking at the complexity, the time complexity is O of m plus n, where m is the length of the magazine and n is the length of the ransom note. We scan each string once. The space complexity is O of k, where k is the number of unique characters in the magazine. Since there are only 26 lowercase English letters, this is effectively O of 1, or constant space. And that is the Ransom Note Challenge mastered. Save this video for your next technical interview, and follow Leo Academy for more such premium DSA guides.